Hello, I'm Ibonalo, also a reporter of Group 1, and I am going to tackle integral calculus. At the end of this video, we would be able to know what integral calculus and antiderivatives are. We would also know the two types of integrals and the theorems of integral calculus. And later on, we will be solving a problem involving the theorems. So to start, let us first have an idea of what integral calculus is. Integral calculus is a branch of calculus concerned with the theory and applications of integrals. When we say integrals, those are mathematical objects or numbers that can be interpreted as an area that is according to Wolfram math world. I would also like to add a few information about integral calculus. So the basic idea of it is finding the area under a curve. Additionally, integral calculus involves what we call integration. It is a reverse process of differentiation. Through integration and with a given derivative, we will obtain a function. Now, how is integral calculus different from differential calculus? Integral calculus deals with the total size or values such as lengths, areas, and volumes, while differential calculus focuses on the rates of change, like slopes of tangent line and velocities. On the next slide, we are going to learn about antiderivatives. So antiderivatives are the opposite of derivatives. An antiderivative is a function that reverses what the derivative does. One function has many antiderivatives, but they all take the form of a function plus an arbitrary constant. So no matter how many antiderivatives your function has, it would always result to a function plus an arbitrary constant. Then we move forward to the two types of integrals, the indefinite integral and the definite integral. So indefinite integral is a representation, usually in symbolic form, of any function whose derivative is a given function. Now definite integral is a representation, usually in symbolic form, of the difference in values of a primitive of a given function evaluated at two designated points. Now, to give you a better understanding or simple understanding of these two, well, the difference of these two is that indefinite integral has no boundaries. And so when you find the antiderivative of these indefinite integral, it would give you a function because there is an arbitrary constant which we do not know. Because there is no boundaries, as we said. While definite integral has boundaries, it has limits. So when you find the antiderivative of it, it would actually give you a real value. Now moving on, we have the four fundamental theorems of integral calculus. So the first theorem is the integral of x is equal to x plus c. And the next theorem is theorem 2, which is actually called reverse power rule. So this rule tells us how to integrate expressions of the form x to the power of n when n is not equal to 1. So we have integral of x to the power of n is equal to x to the power of n plus 1 over n plus 1 plus c. So basically, you increase the power by 1 and then divided by the power plus 1. Also remember that this rule doesn't apply for n is equal to negative 1/2. And then next is theorem 3. If a is any constant and f is a function, then integral of a and f of x is equal to a integral of f of x. And the last theorem is theorem 4. If f and g are functions defined on the same interval, then it would be integral of the two functions is equal to the integral of the first function and the second function. Next, you have a given problem. So we're gonna solve the antiderivative of the integral of square root of x to the power of 4 times 3 over x plus x to the power of 2. So by the way, this is the integral sign, and this dx is just a variable of integration. This indicates that this is a function with respect to x. This is called the variable of integration. So this variable of integration is a dummy variable and has no impact on the computation of the integral. So to start, first we have to change the square root into an exponent, and that would be 1/2. And then we multiply it by 4, the exponent of x. So x to the power of 4 times 1/2, and that would give us x to the power of 2 times 3 over x plus x squared plus c, of course, because we're finding the antiderivative of an indefinite integral. And the arbitrary constant should always be there because we're finding, again, the indefinite integral. And next, we have to solve what's inside the parentheses. And since x squared is a denominator of 1, what we're gonna do is just add both. So 3x squared over x. And then next is we multiply x squared times 3x squared over x. And that would give us integral of x to the 4th power plus 3x plus c. Now what we're gonna do here is we apply Theorem 2, which is also called the reverse power rule. So again, in the previous slide, basically what we do in reverse power rule is we increase the power by 1 and then divide it by the power plus 1. So in here, we have a power of 4. This one. So we add it by 1, and that would equal to 5 over 5 plus 3x squared over 2. Why? Because x actually has a power of 1. And then we add it by 1, and that would equal to 2 over 2, and then plus c. So here we have the final answer, the antiderivative of this given problem.
Hello, I am Adonai F. Sevilla, the reporter Group 1 Blessed Frederick of Regensburg on differentiation. And here we will apply the various rules of differentiation to find the derivative of a given problem. So without further ado, let's get right into it. So first you have to keep in mind what a derivative is. Remember that a derivative is described as a function's rate of change at a certain point, and that differentiation is a process of finding that derivative. That being said, here we use dy over dx to denote that we are taking the derivative of y with respect to x. In the next slide, we have our problem. That is to find the derivative of negative 4x squared e to the x plus 5x e to the x minus 10 e to the x. And here beside the problem and solution, we have the various rules of differentiation, and here we'll keep track of these in finding the derivative. As we go through the solution, we'll refer to these in order to explain why things become the way they are. So let's get started. Alright, notice here that in a given, it is a differentiable function, and it also involves the addition and subtraction of terms in a polynomial. From that, you can assume that the sum rule is applicable, and that you have to find the derivative of each term. That is fine and all until you notice that e to the x is present in all terms. But that being said, you can also make use of the product rule to find the derivative, albeit doing so is fairly quicker as opposed to using the sum rule. So the first step is that we factor out e to the x from the function. So that's why we have e to the x, and the rest here, negative 4x squared plus 5x minus 10. After that, we find the derivatives of each factor, and according to the rule 8, the derivative of an exponential function, the derivative of e to the x is e to the x itself. So that's why we put e to the x under the original term. Next, we find the derivative of negative 4x squared plus 5x minus 10. Many rules can be applied in this polynomial, so let's start with the constant multiple rule, where the coefficients of the terms are multiplied with the derivatives of the rest of the expression. This comes hand in hand with the power rule, where we subtract 1 from the term's exponents and multiply the initial exponents with the coefficients we got from the constant multiple rule. So here, negative 4x, we process this, that's the exponent times negative 4x squared. We subtract 1 here from the exponent due to the product rule. And after that, we go to 5x. From that, we also subtract 1. The x's exponent is 1, that's minus 1, minus 0. Because, remember, according to the constant rule, the derivative of a constant is equal to 0. And that we simplify, that's negative 8x into x's exponent is equal to 1. And here we have plus 5. 5x becomes 5 because of the exponent because of x's exponent, which is 0. It later becomes 0. 5x becomes 5 because of its exponent, which is 1 initially, and it later becomes 0 here, therefore removing x from the term. All things considered, the derivative of negative 4x squared plus 5x minus 10 is equal to negative 8x plus 5. The next step is to cross-multiply the original two factors of the function with their corresponding derivatives and add the two products. So here we add our x, cross-multiply here. This becomes e to the x times negative 8x plus 5 plus the product of e to the x minus 4x squared plus 5x minus 10. We distribute e to the x to both of their cofactors. But before that, we have to combine the like terms ahead to further simplify it. So that's e to x times any common terms, the ones with the highest degree goes first, that's negative 4x squared. And the one at the same degree, we have negative 8x plus 5x, that's negative 3x. And then as for the last term, we have 5 and negative 10, that's negative 5. So that's identical with here. The next step is to distribute e to the x to all terms, and just like that, we have our final answer. That's negative 4x squared e to the x minus 3x e to the x minus 5 e to the x.